Hello everyone. In the previous video, I have seen how to send and how to receive the data from the particular port. Continue with that. In this video, we'll see how can you access the particular bit in a port. Because already we know that all the ports P0, P1, P2, P3 are byte addressable as well as bit addressable. That means we can access the particular bit in a port without disturbing the other bits. So let's consider this example. So here I'm complementing the port P1.2 continuously. So for that I'm writing CPL P1.2. So here if you write the CPL P1 means it complements the all the bits of port 1. If you want to complement the particular bit, so here I want to complement P1.2, so directly you can write P1.2. That means it only complements the P1.2 pin in a port 1. It will not disturb the other pins. So next, call the delay subroutine sjmp back. So back is given to the same instruction. So that means continuously it complements the P1.2 pin in a port 1. So the same program you can write in another way, that is setb, that is set bit instruction, setb P1.2. So that means it sets the pin P1.2 only. Setting the P1.2 is nothing but it makes that P1.2 pin high, and then call the delay subroutine. Next, CLR P1.2. CLR means it clears the P1.2 pin. So clearing the P1.2 means it makes P1.2 pin 0. So previously it was 1, so now it becomes 0. So again call the delay subroutine sjmp again is given to the set b P1.2. So again it sets the P1.2. So that means it continuously makes the P1.2 pin 0 and 1. So this is the another way of writing the same program. So let's consider this example. Write the following program. Create a square wave of 50% duty cycle on bit 0 of port 1. So here now we have to generate the square wave of 50% duty cycle on P1.0. So here bit 0 of port 1 is nothing but P1.0. So the solution is the 50% duty cycle means the on and off state are of the same length, that is high and low portion of the pulse are same width. Therefore we have to toggle P1.0 with a time delay in between each state. So that means complement the P1.0 and in between give the same amount of delay. So let's discuss this program. So first instruction is set b P1.0, set to high bit 0 of port 1. So that means now it makes the P1.0 high, and then L call delay, call the subroutine. So here not written the delay subroutine. So next CLR P1.0. So now the P1.0 becomes 0 and call the same delay subroutine, okay, by using the lcall delay and then sjmp here. So again it makes the p1.0 high, again it calls the same delay program, and then again it clears the p1.0, and then again it calls the same delay subroutine. So that means on the p1.0 it is generating the square wave signal. So the width of this signal will be decided by the delay in the subroutine, because for 50% duty cycle the on time and off time both are equal, and so we are calling the same delay program. So this is how you can access the particular bit in a port.